Okay, advantages and disadvantages of various measures of dispersion. Example 10 and 11, page 224. Okay, the range is the measure of dispersion that's easiest to calculate. However, the range cannot provide a good overview of how data is distributed. For example, this data. In cases where there is an outlier or extreme value, in this data, the 1, 2, and 90, 100 are called outlier or extreme value. Most of the data are in the range of 38 to 60, but 1, 2, 90, and 100, they are outlier. So the interquartile range would be the more appropriate measure of dispersion to show the distribution of the data. Why? Okay, for example, if we say range for this data is 100 minus 1, that is 99. And if some people, they don't know the data, but we tell them that the range is 99. So they may imagine that the data may be from 1 to 99. Means they are not something like that. They don't know the dispersion of the data, how the data spread. But if we give them the interquartile range, okay, this is median, and so this is the third quartile. So average of 50 and 60 is 55, and then this is first quartile. So average of 38 and 40 is 39. So the interquartile range is 16. So 16 and the range 99 is a big difference. So when we tell other people where they don't know the data, but we tell them the interquartile range is 16, then they know that the data spread not that big. Means the data spread just a very narrow only. It spread small. If we tell them the range is 99, they may think that the data spread a lot, but in fact it's not the case. Understood? So interquartile range is a better way to measure the dispersion compared to range. But range is very easy to find. Interquartile range is much harder. And then standard deviation is usually used to compare two sets of data. Okay, so normally if we use standard deviation, they must have at least two data. Standard deviation is used to compare two sets of data. In general, a low standard deviation indicates that the data is dispersed close to the mean. Why? Because we know that according to the formula of standard deviation, or we remembers that the formula for variance, we need to minus mean. Okay, we need to minus mean square. So standard deviation is the square root of variance. So in a low standard deviation means the data is dispersed close to the mean. But with the higher standard deviation means that the data dispersed far from the mean. 华文解释也就是说，如果 standard deviation 很低的话呢，代表说它每一个 data 呢都很靠近这个 mean。OK， 如果很 high standard devision 的话呢，代表说它距离那个 mean 很远。所以就是之前所说过的那个误差，从它的 mean 的误差 mean 加减多少。所以从 standard deviation 里面我们可以知道它是否接近 mean 还是离开 mean 很远。OK。对 standard deviation 是很有用的，而且是当它有两 set data 的时候呢，我们就知道哪一个 data 是比较靠近 mean 的，哪一个 data 是离 mean 很远的。 Yes, you can cook and listen at the same time, as long as you can do simultaneously. But according to the research, for female and female can do things simultaneously, but male normally do things more focused, single thread. Female is more prone to multitasking. Okay, example 10. Calculate the range and the quota range of the set data. Determine the most appropriate measure of dispersion to be used to measure distribution of the data set. And first, the data must be sorted from small to big, but in fact the data are sorted from small to big. So the range is equal to the maximum value 40 minus the minimum value 10. So range equal to 30. Interquartile range is equal to third quartile minus first quartile. So the first quartile is the value of data in the middle position of the part of the data before the median, and for third quartile is after the median. I refer textbook 220. So we need to find the median. Here is median, so the left part have 5 data and the right part also have 5 data. Then we find the first quartile. Within the 5 data, 11 is the middle, so this one is first quartile. And then after the median there are 5 data, in the middle is 21, so this one is third quartile. So interquartile range equal to 21 minus 11 equal to 10. And so you can see there are a big difference between interquartile range and range. Range gives us 30, but interquartile range gives us 10. So if we compare these two, we know that the data actually do not spread so wide. It's just 10. And so interquartile range is the most appropriate measure of dispersion. Why? We need to give a reason, because there is an outlier, 40. Okay, 40. 40 has a big difference with other data. So actually when there is no outlier, we can just simply use range. We don't need to use interquartile range. We only use interquartile range when there are outlier. Okay? For this data, there is only one outlier for extreme value. So you need to remember this. Okay? When there is no outlier, we use range. When there is outlier, we use interquartile range. Okay? Example 11. The table below shows the achievement of 2 pupils in 5 physics tests. So, are these group data? Please answer. Are these group data? Okay. This is not group data. They are ungrouped. It just simply put in table. Seems like it's group data, but actually it's not group data. Actually, Iman's score is 40, 70, 90, 85, and 64. They don't group at all. 40 means the test 1, 70 means test 2. That's all. They don't group, but just write in table. Okay, this is not group data. There are two group data here, ungrouped data here. One is for Iman, another one is for John. Two ungrouped data. Okay, we need to determine who is eligible to be selected and justify your answer. One of them will be selected to present the school in physics quiz competition. And so for Iman, we find the mean and we get 69.8. Okay, we find the average of the marks for Iman. And then we find the standard deviation. Okay, you have to do the exercise. You know that we just square all the numbers and add all of them, and then we minus the mean and square. Okay, we need to square the mean and we get 17.67. So that we do for John. Okay, we do for John the mean. If we calculate, we still get the same answer, 69.8. So if we just see the means, we will think that Iman and John have the same level. But actually, if we count the standard deviation, we find that the standard deviation is only 7.574. Although they have the same mean, but they have different standard deviation. And so Iman's score is dispersed far from the mean, as his score has higher standard deviation. However, John's score is dispersed close to the mean, as his score has lower standard deviation. So as a result, John will be selected to participate in physics quiz competition. The standard deviation of John's score is lower because John's achievement is more consistent.